I'm Jayakeerti. I'm architect cum civil engineering. I'm doing my master's in environmental design of building in Cardiff University. I'm here presenting my working paper on assessing the energy consumption of net zero for building with the life cycle cost and energy and empirical analysis, which is the artificial neural networking. To start with I started my paper by analyzing the energy consumption in India. So not only in India, in overall world, the 40% of total energy used and contributed is towards embodied energy, and 30% of the total CO2 emission is coming from the construction industry. So the problem statement which I worked on this paper to develop my thesis is that the existing standards in India has only certain standards which can support only limited amount of climatic conditions for building energy efficient net zero energy efficiency building in the India. For example, GRIGA only supports the hot climate and humid climate for as the standards for constructing a hot climate and humid climate zero energy building. So it doesn't have any standards for constructing a zero energy building in Kashmir, which is a cold state, and some kind of dry state like Rajasthan. So I decided to do or to explore much more standards, much more materials and strategies to build a net zero energy building in different climatic conditions in India. So the objective is to build a school building in Revit 2019 and to select the states by implementing GIS using software ArcGIS to develop an energy model of the school building and to simulate the building for its energy consumption and life cycle costing using conventional and alternative materials or parameters, to analyze the energy simulation results using an artificial neural networking, and to provide the most energy and cost efficiency building parameters. So these are my methodology. I designed my building and I collected the temperature data from the NASA Power website and developed a temperature map. And based on that, I selected the project location and I did my energy modeling. And the energy workflow is given in the figure 2, which is the conceptual mass elements, creating space elements and creating energy models. And I imported into Green Building Studio, which is also a product of Autodesk Revit, and it did my energy analysis there. So these are the traditional consumption and rates of the traditional materials which were used in the construction of the school, hypothetical school, which I designed. So the annual energy cost, life cycle cost, energy use intensity, annual electric, annual fuel, annual peak demand, life cycle electric, life cycle fuel were calculated from the Green Building Studios for the most coldest state in the India and most hottest state in the India. And these coldest and hottest state were filtered out using the ArcGIS, which is a GIS software for we filtered using the temperature data from the ArcGIS and NASA Power. So these are the life cycle energy cost and consumption of Rajasthan and Kashmir. From this, for all the 4 states, I considered Tamil Nadu and Uttar Pradesh because Tamil Nadu is a place where we can see both the it has both hottest days in the year and coldest day in the year. And Uttar Pradesh I considered because of the population, because population also plays an important role in yes. Okay, the important role in the thermal comfort because of the population. So I considered 4 states, and I chose from those 4 states, I chose Jammu and Kashmir and Rajasthan because of their climatic condition, as I told before. And these are the alternative which I tried. And these alternatives I took it from these simulations were did in Green Building Studio, and these materials I selected using the literature reviews. So from this, I chose the best alternative materials for all the wall alternatives, roof alternatives, HVAC alternatives, and orientation alternatives. And from these results, I did the artificial neural networking. The artificial networking, the input which I gave was the standard, the net zero energy standards which I took from the GRIHA, and the output is the results which I got from the previous alternative results, which is the energy consumption and the cost in rupees. So from this, I did my artificial neural networking in MATLAB. And as we know, the regression should be between 0.9 to 1 to get to validate my results. And all my results reached the point of 0.99 to 1. So the results which I got via the simulations in Green Building Studio is been validated. So the conclusion is that though I can't see much improvement in energy efficient building in using alternative materials, but there is a mild increase there is a mild improvement from the traditional materials. Like, for example, in constant consumption for orientation, 180 degrees is the best orientation for the particular school location. And it has reduced by 0.0, reduced the life cycle fuel and electric by 0.03% and 0.009%. Similarly, it has a certain amount of reduction using all the alternative materials. Thank you.
Thank you very much. Now you can breathe. I was exhausted. Huh? Okay, no, thank you very much. Any question from the public? Yeah.
Thank you so much. It was a lot of information to digest, but I look forward to reading your paper. I was just wondering, in terms of the comparison between your study and what would be a typical benchmark for the location, just to have an overview of how those perform versus, maybe I lost in your presentation, but just to have a rough idea.
So the comparison is between the Griha standards and there is an ENBC standards which is used back in India. It's an energy code for constructing the net zero energy building and net zero carbon buildings in India. So I use that values for as a standard, base standard, to feed it in ANN. And the rest of the values, I did it on my, like I said, I chose materials from literature reviews, and from my analysis, I chose the materials and I compared this with the standards. So I gave input as my values, my analysis and literature review analysis from Autodesk Green Building as my input values, and output values taken from the ENBC and Griha. So from this, the ANN values show, after the regression, the ANN value should be 0.9 to 1. So as it reached between 0.9 to 1, so it's like a futuristical regression. It says that this alternative materials could be energy efficient, and reach up to these standards.
Thank you. Any other question? Yes.
So just to conclude the things, what is your vision behind presenting these, ideas?
Sorry?
What is your vision behind presenting this presentation?
What is the
vision?
Oh, so vision behind this presentation is like we have ENBC and Griha, right? But these ENBC and Griha doesn't support all the climatic conditions in India. As we know, if you look at the ENBC standards, it supports on. So sorry for that. So back there in India, we use ENBC and Griha, mostly ENBC, which is the energy code for building net zero buildings in India. So these standards supports only certain climatic conditions. So these climatic, but India is a vast country, and it has a very different climatic spread throughout the country. Those standards cannot support in all the climatic conditions. For example, ENBC suggests some certain materials and certain strategies to reduce the energy consumption and reduce the carbon emission. So that can be suitable only for certain climatic condition and not for all the states. It's not suitable for all the states. So what I wanted to explore was to do trial and error method with 4 different climatic conditions. One is the hottest state in India, which is the Rajasthan, which I filtered out using the RGs. And another one is coldest. And another, I need a mix of both hot and cold. So I chose Tamil Nadu. And Uttar Pradesh is the most highly populated state in India. So I thought, as we know that population and the working conditions of the state also plays the thermal comfort in its location. So I chose Uttar Pradesh. Out of these 4, Rajasthan and Kashmir were varying results. So I just chose those both for analysis in this.
Okay, thank you very much.